This is a demo of the RDF graph feature of Oracle Database. In this demo, we will show you how you can run Sparkle queries and do some other operations like loading an RDF graph into the database using two tools. One is the SQL Developer tool, and then also the RDF server and query UI interface. So let's start with the SQL Developer tool. SQL Developer is a very popular tool for running SQL queries. And we'll see here that we have a Sparkle plugin that enables you to easily easily run Sparkle queries. And you can see here that on the left, we can see the RDF graphs that you have stored here. And we also call them models. And we're going to run Sparkle queries against this data that has been selected. So this LMDB data set has information about movies, the different genres they belong to, and information about the actors who acted in that movie and so on. So you're running a Sparkle query against the LMDB RDF graph that is stored in the database. And then the next query shows, of course, the feature that RDF is uniquely suited for, which is accessing external data sources and querying them. So this movie data set that we have in the RDF graph in the database contains information about the movies and actors. It does not contain any information about the actors themselves, like about their families and so on. So in this query, we will connect to an external data source, dbpedia, that does have that information. So you can see here that we are connecting to the dbpedia external source so that we can get information about, for example, Tom Hanks' birth year, the name of his spouse, and so on. So RDF, of course, and Sparkle is very good at querying across RDF graphs in different data sources. So that's what we're demonstrating here with the SQL Developer worksheet. Next, we're going to look at the RDF server and query UI interface, which enables you to run Sparkle queries against a Sparkle endpoint that uses the REST API. So first, we'll start by showing other operations, starting with the load. Before we do the querying, we're going to load a data. We're going to load a new RDF graph that contains an ontology that will be used with the movie data that we looked at earlier. So in this ontology, you have this, I believe, in an n-triple format that is now being going to be loaded into the database so that we can use it for the query. And we can take a look at the ontology itself just to kind of, so that you can see what we are loading here. So this ontology now classifies the different movies, creates a class hierarchy that classifies the different movies according to their types. For example, the genre romance class includes movies that belong to the subclasses romance, romantic drama, romantic comedy, romantic film, and so on. And romantic comedy films can also belong to the genre comedy class. So you can see here that classes can belong to different genre classes and so on. And this is the kind of relationships, of course, that RDF can represent very well. So we have created this ontology to work with this movie data set that we have. And now we'll go back to continuing to load this data. So the first step when we load an NTRPL file or an NQuad file is we load it into a staging table in the database, which is particularly well suited for like bulk load operations. So if you're loading a lot of data, this would be the recommended approach. You load data into a staging table first, and then as is happening now, okay, you load the data into the staging table, and then the next step is to load data from the staging table into an RDF schema or into an RDF graph in the RDF schema. So the RDF schema is specialized for storing and managing RDF graphs. So the next step is to create an RDF graph from the staging table that would be in the RDF schema. So we gave it a name. We selected the staging table is loading from. And now there are some other parameters you can select if you want. And once you have done with all your selections, you create the RDF graph. So the RDF graph is now being created from the NTRPL file that you had loaded into the staging table. So now you can see you have the new graph that you loaded, also along with the other graph that you had in the database. And we'll be working with the virtual model, because the virtual model includes the movie data set and the ontology that you just created. So it's not a physical copy, it's just a virtual model that combines these two RDF graphs virtually. So you can now run queries against that graph. You can see we have selected that on the left, and now we're going to start running queries. So now these queries are going to use the ontology and answer queries about the data set. So select the number of movies that you have that belong to the class genre romance. And here's the number of movies that you have. And now we can select 10 of the titles that belong to the class genre romance. So they would belong to some of the subclasses, and the subclasses are part of the genre romance class. So you can now retrieve 10 titles. So they could belong to either romance, romantic comedy, romantic drama, any one of the subclasses that we saw. And now that we have seen that, we can now run some more queries using the class hierarchy that we had created. We can say now, let's look at the count of movies that belong to one class, but do not belong to another class. So belong to genre romance, but do not belong to genre comedy. So because we have this class hierarchy, you can have all of these interesting queries against the movies that through the ontology are classified into different categories. So this one is saying, find me the count of all the genre romance movies which do not belong to these other categories. So we hope you enjoyed the demo, and it gave you an overview of the tools and interfaces that you have available to you when you use the RDF graph feature of Oracle database.